I'd now like to discuss the structure of a C program. Now, what do I mean by the structure of a C program? Well, imagine you've got a C program that is running. You've written yourself a C program. It's compiled of several .c files. In other words, you might have a .c file that contains all your string manipulation functions. You might have a .c file that contains all your printf stuff. And you might have another one where all the calculations are done, or whatever. It's completely up to you how you organize your .c files. But you may have several .c files. So let's imagine one great big .c file, one C program running. What is it comprised of? What goes into it? Well, first of all, you've got a bunch of .c files. These are the ones that you have written yourself. One of them, of course, will contain a main. But what else is there? What about all the code that you didn't write yourself, like the printf and the strlen and the scanf and the fputs and all the other ones that we've seen? Well, they come from the standard C function library. So your program is also going to involve those as well. In other words, your program is going to contain libraries, not just your .c files. There's going to be libraries involved as well. There may be more than one library. Obviously there will be the standard C library. It's pretty hard to avoid using that, although it is possible. Also, there are likely to be other libraries. These might be libraries that have been purchased by you by paying some money to a vendor of libraries, or they may have been libraries that came with your operating system. An example of that might be the math library. There's a standard C library, and then there's also something called a standard C math library, and they're not part of the same library. They could be, but they just happen to not be. There could also be libraries that you have created yourself. Now, we're going to talk more about libraries in this module, so I won't go into libraries now. So if you don't fully understand what a library is, then we'll get to that. But suffice this to say for the moment, it's code that has been written and has not been written immediately in the .c files that go up to making this program. In other words, it's reusable code. Code that's been written once before and is being used now and will probably be used again in some other program at some other time. So, to summarize, you might have written 10 lines of code. Your 10 lines may include a printf, a scanf, and a strlen. When you compile that program, depending on the compiler, you will find that the .exe, the executable program that comes out the end, will be, well, considerably large. It might be 50 kilobytes of code. It might be. It depends on the compiler. It might only be 5 kilobytes. Again, it depends on the compiler. And you might think to yourself, where did all this extra code come from? I've only written 10 lines of code. How can the program be so huge? And the answer is, of course, there's all these different libraries of code that get involved. How do they get involved? Well, they get automatically involved. Usually they get automatically involved whenever you say a line like printf in your .c file, the compiler goes off and hunts down the library that contains the printf code and links that in to the program, thus increasing the size of the program. I'm showing you this because it is just a good piece of information to have when you're creating a large complex C program. Anyway, the next module that we're going to have a look at is going to be how the compilation happens, all the different phases of compilation.